So you might have noticed AMD is launching some stuff today. MI350 and 355X. That's a air-cooled and liquid-cooled, 1,000 watts and 1,400 watts. It's the same hardware. It's just, hey, if you can do liquid cooling, you get 1,400 watts of power dissipation. 20 petaflops of FP4. That is, that's a lot of compute. 288 gigs of HBM3E. They're also launching the preview version of ROCm 7, the software side of things, which we'll talk a little bit about. But new data center stuff. This is not a refresh. They've actually done a lot as far as hardware goes. If you haven't seen AMD's press release, you should go watch that and then come back here. There's a few things we need to discuss. So, Instinct GPUs for the enterprise. That's really what we're talking about. That's CDNA. Gaming GPUs, that's RDNA. We have not yet reached the road where we talk about the eventual merger of those things. They're different. Well, they're kind of combined on the ROCm side, and there's AMD's commitment to open on ROCm 7, which we'll talk about. But on the hardware side, we're really just talking about CDNA today. And just to be clear, CDNA and RDNA, and then there are APUs. Things like my Graphics 1151 HP G1A laptop that I did a review on, and there's an Arch guide for, which we're also going to talk about in the context of the ROCm 7 thing. Those are three different things, three different targets that ROCm has to support. And yeah, well, let's talk about the hardware innovation first. This is no mere refresh. AMD's gone to a new 3nm process node for the chiplets and a new I/O die, and the performance is really impressive. They've gone to a true 3D packaging strategy from the 2.5D packaging strategy used in the MI300, and that's just giving them more power budget to throw at the XCD compute chiplets. And boy, they have. And they shared block diagrams and some interesting stuff with how they designed and redesigned things. They've gone to 2 I/O dies instead of 4, which supports NPS2. There's no point in running multiple GPU domains in NPS4. And CDNA supports SRIOV, so that you have true hardware memory partitioning and all the security and everything else that goes with that. Just a nice enterprise feature. It's nice to see that. Wish we had SRIOV on RDNA just for giggles for the home lab, but hey, this is really awesome to see in CDNA, and there's a lot of enterprise customers that are really going to benefit from this. Because again, remember, 288 gigs of HBM3E, it's going to run a lot of instances of Llama 70B, or even just one instance of a 500 billion parameter large language model in Q4, which is FP4, which is sort of nuts. Now, the design changes for MI350 would seem not to leave the door open for the 350 and 355 refresh to have a product like the MI300A refreshed. And that's because MI300A, you could swap some of the GPU compute chiplets for CPU compute chiplets and then have a really big APU. Maybe we'll see that with MI400, but there's no hints of that in this refresh. Now, AMD, for their performance slide, it looks a little weird. It can be a little misleading. If you look at the MI350 versus the 355X, and you look at like the FP4 performance, we're dumping 400 more watts into the liquid-cooled option, but we're only getting like 9.73% more FP performance. These are peak numbers. These are not sustained. The sustained numbers are actually about 20% higher, but it's hard to represent that in a slide because that's just how it works. The liquid cooling, the peak power dissipation, there's a lot of variables that goes into that in terms of like the silicon design. And so this is really more about sustained power rather than peak power utilization. So even on the MI300 or the 350X, you can get some really absurdly high peak floating point numbers, but it's the sustain that's the big difference between air-cooled and liquid-cooled. And so in reality, if you deploy a liquid-cooled solution, it's going to be about 20% faster compute unit for compute unit. Now, it also supports a higher density. I mean, you can deploy 128 GPUs per rack with it as well, versus, 64 for air-cooled. The other breakthrough for AMD is that the MI350 solutions can be fully open in the whole rack, open compute. I'm talking about networking and physical infrastructure and the fabric and everything that goes with that. The Pensando team has been hard at work on AMD Polara. AMD is calling it the first AI NIC. We'll come back to that. But the thing with this is that Meta shared that 10% of the problems that they have when they're bringing up a new model are networking related. And it's really just dumb stuff on the networking fabric. And so when we say networking fabric here, we really just mean like the GPU fabric. Like I think that's a similar term to what competitors would use. But the GPU fabric is responsible for like 10% of the stuff that they encounter that they have to deal with. And so Open Compute and AMD have been in the process of agreeing on some ways to mitigate that, and Pollara implements that. And so we should see a more reliable GPU fabric that is less likely to encounter those, 10% of things have an issue when we're doing training or inferencing or whatever. So that's good. If you're into the Open Compute scene, that's Ultra Ethernet. And so Ultra Ethernet shows up here. It's implemented in Pollara, but Pollara is more than just Ultra Ethernet. This whole rack ecosystem is also hugely important for the future. So we'll talk about that a little bit more because I want to talk about the future roadmap stuff that AMD shared. But today, you can have up to 36 terabytes of HBM3E in a single rack, which is way more than competitors, and it's something that AMD is leaning on heavily to differentiate themselves from a competitive standpoint. I mean, I'm sure that NVIDIA enjoys more margin if they can convince you that they need less, or that you need less VRAM in order to do your jobs. But, AMD is really leaning heavily into VRAM all the things. And so as I think sophisticated buyers are probably going to be interested in the VRAM capacity, but we'll see. We'll see. So what about the software side? Well, that's ROCm 7. And ROCm 7 is now in preview. Now, this is a little weird because ROCm in general is kind of a rolling release. They're moving to a rolling release model. We did a video on the ROC under the ROCm GitHub. You should check that out. That is basically a rolling release implementation of ROCm. And so version numbers and a rolling release kind of a scenario. I mean, that's a conversation for another day. But ROCm 7 does offer significant performance improvements, especially on CDNA, over prior versions. Now, for me, I'm trying to get ROCm and the ROC to work on bleeding edge, graphics 1151 laptops, the HPG1A. That's RDNA. That is not CDNA. Most of the support, it seems, for graphics 1151 from just looking at the raw GitHub is actually coming from the community. There are community developers outside of AMD because I think AMD has been really busy with the CDNA bring up. And so most of the stuff that I have on my laptop is that. It's also more geared toward LTS kernel support. And this is a really interesting sort of disconnect because on the CDNA side, sure, in the enterprise, everybody is concerned with the long-term support kernels, the LTS kernels, LTS distros. Nobody's running Arch on their giant GPU supercomputer. But for laptops like the HPG1A, most of the work that's being done to bring up RDNA is at the bleeding edge Mesa, bleeding edge kernels, power management, Hibernate, all the stuff that you have to worry about. Even the I2 bus is all bleeding edge kernel stuff. And so there's this disconnect where it's like, okay, I need ROCm to work on both ancient kernels and ancient LTS kernels, as well as modern kernels. And the housekeeping hasn't really been done. So I created a thread on the forum where I'm literally trying to bring up graphics 1151 on ROCm, and I'm patching things in ROCm to get it to work. I tried to get it to work with CMake 4.0. It still requires CMake 3.5, which again makes sense on an LTS distro, but not so much on our HPG1A with Arch Linux. I rolled Arch back to CMake 3.5, but it also has a newer clang, and so compiling with that is sort of a pain. So there's a thread on the forum. You can follow along there if you want to on the ROCm side of things. But ROCm does look like it's going to be a really solid. I can't believe how far ROCm has come in such a short order, especially for CDNA, especially for these performance gains. And so AMD is putting a lot of money behind this, but also it seems like their partners are and the community is. And a lot of people have access to this hardware. So that's encouraging to see that with ROCm. Also check out the future roadmap hints. 2026, right around the corner. Well, it's probably about a year from now, I'd say maybe more. And we'll see the next gen EPYC and Volcano NICs and the MI400. AMD calls the MI400 compute rack solution Helios. Like the sun, like the amount of fusion it's going to require to keep it powered. And the side-by-side numbers versus Vera Rubin look pretty good. MI400 looks like it's going to be pretty monstrous with its 40 petaflops of FP4 and up to 432 gigs of HBM4. This is just a preview, though, so we'll see how MI400 shapes up when we can actually get some benchmarks and run it in the cloud and that sort of stuff. Oh, speaking of the cloud, AMD has just turned up an insanely huge cluster to give developers and anybody interested in the CDNA ecosystem access to be able to preview things. And so I know like Supermicro had their solution, which was really popular. And AMD said, oh, we should probably do that for a lot of our other customers. And so there's a lot of details about that. Hit me up in the forum or check out the forum thread. They're still working on the logistics of that at the time that I'm working on this video, but I think they're going to have more announcements about that in the actual live video that AMD did. But it's basically a cloud environment where you can get free credits. It's like, okay, I want 24 hours with a CDNA GPU. All right, here you go. They'll turn you on. Also, notice in this roadmap, EPYC in 2026 and 2027. Yeah, new EPYC CPUs. We get new code names. We've got Venice and Verano. So that's pretty exciting. It's pretty awesome to see some of this stuff in person. There's a couple more things that I've got that we can't talk about yet, but this is it. This has been a quick look. I'm Wendell, this Level 1. I'm signing out. You can find me in the Level 1 forums. Let me know what I missed. And if you want to help bring up the graphics 1151 on my HP G1A with the latest, the ROC, let me know. All right, hit me up. See ya.